And good evening everyone who is watching the stream of VOD arrives on air, and welcome to another soldering stream. So I want to finish up with these cables tonight. So this is kind of pretty long project. These cables are needed basically to connect two audio cards of two separate computers together to be able to just catch sound from one audio card on another audio card, and basically this is needed to stream double vision DZ, to do double vision DZ streams when like two players are pretty much sitting next to each other. So these are patch cords. They would be connecting audio cards using these devices breakout box cable extenders. So the audio signal goes in here, and there's 4 of them, and then it goes out here using just RJ45 twisted pair category something 6 or something. It's supposed to be shielded though, so the category maybe it's not that is not that important, but it has to be shielded, the cable. So it's way easier to run just one category something twisted pair cable with 4 pairs in it, so Ethernet, than like 4 of these between two computers. That's like, yeah, that's a lot. Plus this costs more. These are like good microphone professional cables. So that we've done already. 4 done, 4 patch cords done. We need a little bit more. We need 4 more. So let's actually see if I have enough plugs for that. So that's for one, that's for another, jack plugs. And then this one reused for like one, and then this one for another. So exactly I have enough of them to do 4 cables. Okay, so these ones are amphenols, the best stuff, pretty expensive. That's why I'm reusing actually. Oh, wait a second. Where did this one go? I have one spare. That's interesting. So give me a second. What's going on in here? Have I lost one? 1, 2, 3, 4. No, there's okay, no, everything's just right. They look so similar, but they are different plugs. So this is amphenol. It's like $7-8 here, maybe 6 if you look really good, but yeah, they're pretty expensive, so I'm reusing it. So an amphenol side would be for my for my main audio interface, Focusrite Scarlett 18i8. So the expensive plugs, the expensive jacks are for the expensive card, and the rest of them for less expensive stuff. So here we go. Okay, let's start with cables. I already have cables pre-cut to the length. So there's one mistake in here, or maybe actually not. So there's one shorter, but the one that's shorter supposed to be connected into the front panel. The ones that's longer supposed to be connected into the back panel. And I'm cutting them. I cut them like 100% to the length because, well, I just absolutely don't want to have any excessive cables left anywhere around. So I have a feeling that this window is sort of kind of in a wrong place. I always end up. Okay, if we just move the camera a little bit, make it like this, then check the focus, like using this thingy. It's long. Seems to be more or less in focus. I use cameras with manual focus, so got to care about focusing them myself. Okay, so let's start working on the cables. First, always put this on. Do not forget about it. The case, the casing, and the sleeve, the plastic sleeve that protects these two mostly from accidentally connecting to the casing, to the case of the jack. Okay. Let's unbend them. How do I need to move my cam to actually have it more or less in the frame, like this? Just give it a second. So, to have it in the frame, the keyboard's getting in the way. Maybe like this. Maybe like this. Trying to frame everything properly. Even like this. Yeah, more like this. Framing is I literally need to draw a frame here on the desk to remember where is the camera view here. Okay, and I don't want to zoom in for now because that's sort of kinda makes it even harder to keep track of the framing. So I'm not using any strippers here. I'm cutting the insulation, all insulation here manually. It's a dull knife, and I'm not doing cutting movements back and forth. I'm just pressing it in. So just to accidentally not cut the strands of the shield. This cable doesn't have any foil in there, so it's just this shield consisting of strands. So because it's a microphone cable, kinda, well, they call it professional, Klotz MY206. They call it professional because it's sort of professional. It has to make it more well, it's not solid, more reliable, more, what's the right, more durable. It has two pretty much ropes inside, when you start working on the cable, preparing it for being soldered, these ropes unfortunately all untwist into just separate strands, which is annoying really. So the same trick I'm doing with this side, with these wires here, just trying to be even more careful. So maybe there are cable strippers, that insulation strippers, that will just do the job without losing any strands, but the ones I tried in my life, they would usually cost some strands lost for the wire. Using a knife, especially if it's like not really that sharp anymore, it's way safer. It kind of pushes through the insulation, but cannot really that easy push through the copper of the wire itself. The insulation on these ones, it's very solid. No joke. Takes a little bit of time and precision to remove it without overbending the wire itself. This, yeah, okay. Overbending the wire itself or losing the strands. I'm kind of doing it for myself, and I'm kind of doing it the best way I can, with the highest quality I can make it with. A little bit hard to cut through them when you cannot put a finger or something else underneath. Made the music a little bit quieter. There's maybe a little bit of it left, and it's still holding the insulation on the wire. Very solid insulation. Okay. Yeah, and see, all this cotton got untangled. Okay, let's start soldering. Let's cover them in solder first. Resolder them. This cable is good and the jacks are good. They all take solder like really well. Well, it's proper copper, this here. You don't need to sweat it. It just sticks pretty much without heating up half of the cable to the start temperature. Just don't forget to add some flux. Okay. So now I specifically oriented crap. Always get out of the frame. It's insane. I specifically oriented everything this way so that the red one is there, the blue one's here, and the shield is on the bottom, because that's how it's supposed to go into the jack. This get entangled always, so just can maybe add a little bit of solder to the tip of it to prevent it from untangling and twisting. Yep, like this. While I'm just putting it in. So this has to be cut to make it a little bit easier to go in. And then maybe I'll cut them some more. This one a little bit harder. Oh God. Go in. Like this. Now this rope part gets out of the way. You're supposed probably to cut it, and I think you're supposed to cut it, but I just kinda turn it back and try to then pinch it, crimp it in the crimping part of the jack. So that's how you're supposed to solder it. That's like perfect. Oops, that's far from perfect. That's mostly flux there. But now there is a lot of solder under that flux. Here we go. That part's done. Now this part, as you can see, the most probably important part, there's no exposed free parts of these wires. They are soldered pretty much straight, well, not onto the insulation, but to the insulation, to where the insulation actually ends. Okay, this I'm going to do. So let's cut. Maybe do it like this. I'm not cutting it just yet. I'll cut it a little bit later. So First, let's solder this one. This one's not pre-soldered, it wouldn't go through the hole otherwise. Wouldn't fit. So I just do it a little bit dirtier, like that. Form a big blob. Let it soak into the twisted shield, and then just cut it, trying to make this blob as flush as possible. That tends to fly away. So like this. It's still there, it's not going anywhere, it's properly soldered, but just the very end of it. We can add a little bit more just to be on the safe side. Because I cut it and I could see that we have the strands of the twisted strands of the shielding not soaked in the middle with solder. Okay, now let's just crimp it. Okay, that's supposed to be enough. Now the protection, like this, and then the hard part that's sometimes not easy to screw on because it gets a little bit tight in there because of all the solder blobs. Okay, one side's done. Just a second. Now another side. Red to red. Trying to reframe it again, give it maybe a wider angle. Like this. Then the knife like this. Is it out of focus here? Sort of a little bit, so let's try to focus it in between somewhere. Okay. Like this. So this is oriented like this. So then this goes under these two wires like this. Now these ones. So this knife actually is a little bit dull even for these wires. For the common insulation, overall insulation, it's sharp enough because it's soft. This one, it's sort of a different deal. No strands lost, I think. Another one. So here just need 8 patch cords. This is like the 5th one, and I'm a little bit late today. Well, this is Saturday. I usually don't get a lot of free time on Saturdays. Usually there's a lot of family things to do, housekeeping, house cleaning, taking care of things, shopping again. Even if it's something like grocery shopping, still takes time. Home improvements again. Actually, keep forgetting to post one of the pictures. Not with home improvements, but with the reason for home improvements. Okay. Solder. And yeah, I solder using a very old method. The solder that I use is modern, but the flux is just pine rosin flux. It's natural and smells good, but it gets your soldering iron pretty dirty pretty fast. Which is not a big deal if you solder things as big as this wires. Okay. plug. Here we go. Cut the excess of it. The tabs a little bit, move them a little bit out of the way. Like this. This is the easiest part. Just one touch with soldering iron and you get a nice blob that connects everything very nicely. Bend it a little bit upwards somehow. Maybe they will bend a little bit upwards. Then the same for another, for the cold. Okay. What about a little bit more just solder in there, like this. A big blob. Here we go. Now the shield. Kinda gets hot a little bit, that's why I'm not holding it. And when you're not holding it, it tends to move a little bit when the solder melts. Now that I do not that much like. Just like this. Overheated it a little bit. Yeah, you're not supposed to overheat them. These rings here, the plastic is inside, plastic is in here, so do not overheat these while soldering, especially the ones from AliExpress, I think. Okay. The inspection. Here we go. This goes here. This goes here. Then we just push it together. And then we use pliers. Like this. Maybe I should move the camera a little bit like this. Yeah, I keep just moving and reframing everything, trying to figure out the best way. Okay, but this one's done. even without big blobs of solder sticking out. So let's test it. Need the tester. Oops. Okay. Continuity. So first the shield. Showing no 0.3 ohm. Yeah, that's just the connection of the tester itself. And the ground is not shorted to anything. Now the ring, not shorted to anything, connected to itself. And then the tip, not shorted to anything, connected to itself. Okay, this one's done. Another one. Where's another one? There it is. So one cable in 40 minutes. That's kinda pretty slow. Got to try to do it faster. But that was the first one of the evening. Here we go. Cutting it, removing the insulation. Seem to be unable to find the right camera placement tonight. Maybe I need it higher. Yeah, I think I just simply needed higher stand for it. Here we go. Repairing it all again. So we have what I would call the plane of the cable, but it's only a plane here. It's not like something constant. I think it turns inside the cable even. The structure of the cable, it goes like this inside of it, slightly twisted. No, I don't need this cotton inside of my twisted shield. Okay, now cutting these. These are the most annoying actually ones to strip insulation off of. Really good insulation, really stiff. even just a tiny little breach of insulation left uncut stops it from moving off of the wire altogether. This plastic is like super solid. Here we go. Once done, the next one. So, of course, I'm not trying to make a challenge out of it, but I want to do it as fast as possible, as fast as I can, not losing in quality. Just learning to cut them faster, just the right amount pressure to apply, to cut through the plastic but not through the strands of copper. So here's a little breach of plastic in here. Okay. Roughly the same length. Now here comes the sun, not the sun, the solder. Dun, 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 dun. And if you hit it up properly, you don't even need to touch the other side. But to hit it properly up, you need to have enough flux on your soldering iron on the tip. Boom, 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 boom. Okay. Oh. Okay, let's cut them right away. Now you go in your hole without unstraining and untwisting and losing random strands here and there. Like this. All this. You go here. And the blue one seems to be a little bit away. Let's pull it to its place. Just with a lot of force. Like this. Now you lay flush in there. You too. Like this. pad of the tab like this. Do not go anywhere. Here we go. Perfection. Then this one. I think the way we are soldering it, the most important part is this, kind of the back of it. And they make you a little bit more flush somehow. It gets dirty pretty fast. Plus I'm using burnt flux already. The tip gets pretty dirty and flush. And the flux that I'm using, yeah, I gotta take a new piece, or at least turn this piece over. Okay, there's not enough, clearly not enough connection there. Can I please have the cable turned properly over? Now it's more like this. It's more like it. More like what we need. Now cut the excess of it. Still hot, of course. Can see some strands there. Let's cover them and solder. Like this. After cutting, again, cut the excess of the wire of this braid and ended up instead with a blob of solder. So one way or another I made it larger. Okay, this one's ready. Crimping it. I don't know if there is a special crimping tool for these ones. I'm just using pliers. Seems to do the job very nicely. Okay. This goes back on like this. Protecting the contacts inside from contacting the casing. Okay, no, the blob I left on and there wasn't that big to prevent it from being screwed on the case, I mean. Here you go, and you go then there. We just open to make things easier for us, and you a little bit like this. Then we sort of measure it. cutting. More like pushing the knife through than cutting. This, I suppose. Here we go. Now the hardest part of it all, removing insulation from these inner wires, hot and cold. Probably there are strippers, insulation removers in the world that would be able to remove insulation off of these wires without losing any strands of them, any copper inside. But yeah, those I don't have. And when I'm cutting the insulation with the knife, if I start doing the cutting movement in case of really hard insulation, really stiff and hard, then when I actually cut through and when the blade touches the copper, I can feel it immediately. So the movement of the knife changes. But again, cutting it back and forth, it's a little bit dangerous. Just, I think, only a thing for people who are like audio technicians that would just have to work with cables like this ones a lot. And of course, like probably, of course, good audio technicians would solder, would make their own cables, but they would have like hundreds of them. Did they lose a strand? Doesn't look like it. Okay, I I think I lost a strand here. Oh well, just one. The solder. I don't know, I'm using like the solder with the lowest temperature of melting. The combination of tin and lead with the percentage of tin and lead. I don't remember the exact percentage, but the one, that one that provides the lowest temperature of melting. So like percentage of tin, percentage of lead and whatnot. Maybe you're supposed to solder this with something a little bit higher temperature. This is gonna be a little bit harder, I think, because I left them pretty short. You don't untwist. This. But even if they're short, you still can put them in there. Okay. Oh no. Okay, you don't want to go there like that. Then I'm changing hands. Like this. A little bit of solder, a lot of flux. A little bit of solder actually happened the other way, exactly the other way around. A huge blob of solder and a pretty moderate amount of flux. Okay, that's how it's supposed to be. That's like perfect soldering of these things. This blob is a tad too big, but it's just a matter of doing things perfectly or not perfectly. Okay. Now you gets hot immediately, this part. I mean, if you solder these things often and a lot of them, then you would probably just get used to this thing heating up in your hands. Like this. Cooling it down, then cutting it flush. Like this. Let's add just a tad more solder on top. After cutting that twisted shield, that's actually pretty thick. No. Properly crimping it. Nope. Yep. Okay, the second one's done. But first we got to measure it. Well, measure. Test. Okay. You go on there. Perfection. The second one's done in 15 minutes. Okay, that's better than 40. The tester. So the shield connected to itself, not shorted to anything else. The ring. The ring connected to itself, not shorted to anything else. The tip, not shorted to anything else, connected to itself. Okay. So the ones that are for the less expensive audio card are done. Now the ones that are for more expensive audio card. That's why one end is going to be Amphenol. Okay, but let's start with not Amphenol part of it. You get unbent, you get a little bit spread out. Like this. Then where's the freaking focus? Like here somewhere. Okay. It's not in the frame, never in the frame. It's supposed to be like really close to the surface of the desk for you to see, like here. What if I move it? No. Don't know. Framing seems to be super hard tonight. Okay. That's my pocket. All the strengths of the shield go together like this. Okay. Now the hardest part, this insulation here. Get out of the way. So yeah, tried to do a little bit of cutting movements and immediately lost a strength, which is not of course a big deal, but since we have an OCD here, that's an OCD soldering stream. Everything has to be perfect. Perfection or bust. So got to be really careful with any cutting movements on this. Better just to push through. This one's better. Now pre-soldering. Dirty, very dirty tip. Actually, my tip has a super strange shape. I got to take a file and make it just standard slanted. Its shape is like super strange. I don't know why. Probably I needed it at some point for something. Since then, never cared to get it back to normal. More common shape. Okay. Cutting the excess of it. Excessive. Linked. Now go in your hole here. like this. And then you go where you're supposed to be. Like this. And then like this. More or less, well, more actually than less, right? And the blob, here we go. There's a little bit of flux, not a big deal, not going to damage anything. You and you are done too. Now this one. If you bend it, so it's like microscopic tips and tricks for soldering just the this type of connectors, tips and tricks that we are coming up learning on the way. So if you just bend this braid past its side down, well, down just to the other side, well, I mean across the diameter of the connector, it'll then, when you center it back, it'll align a little bit better with the, stick a little bit better to the surface of the tab. Okay. Just take a lot of solder. Okay, I really need to get new flux, new pieces of flux, because I'm actually, oh, there's a burn too. Well, I mean, I replaced the pieces that are all boiled and burned with the new ones after them. Just gotta try to stick the tip of the soldering iron into those sides of the pieces that are not boiled to just dark brown. Just like this. Crimping it. Like this. Maybe let's cover this part a little bit with, add a little bit more solder to the side again, like this. I learned to cut them really flush through all the solder and all the braid of the shield, so flush that in the middle of the braid you start seeing the strands that are not soaked in solder. Okay, I need a short break, or maybe not that short, so just a second. We will continue after this break. again, and I'm back. Hope you can hear me. So let's continue with our cables here. So this one goes here. So unfortunately, the amphenol jacks that I have, they don't have the right diameter of the gasket here. So you got to really push it through then. It's a rubber gasket, sort of rubberized, so it would go through, but you're supposed to use the right diameter. At least I know that at least here, two diameters of the gasket is available. Absolutely the same jacks, just different gaskets. And plus, I think you can change them. It looks like it. Because it's a different manufacturer, amphenol, the way it's done, it's a little bit different too. The design of it, not wildly different, but kinda more different. More different, just different. Again, but the way you prepare the cable here for soldering, it stays the same. So got to figure out the plane. Or just twist it into the right plane. Get this cotton stuff out of the way. Prepare the shield. Like this. Then the hardest part, removing the insulation of these ones. They are pretty stiff, keep saying that, but what else to say here, that they are super stiff. That side, there's a bridge somewhere still left here. Here you go, cleanly removed. Twist. The next one. in the same length of insulation removal. So I'm cutting it on my finger, and my finger works as a limiter for the blade. The surface of my finger works as a limiter, limits the movement, doesn't let it cut through anything, really. Strange way, but reach somewhere. Another one. Here we go. Now the main difference between the ones from AliExpress and these ones that from Amphenol, it's the way you put the attach the shield to it. There's like a crimping tab, so not just a hole, a crimping tab in there. So you can maybe try to move it through the hole, or maybe just I actually managed to crimp it and then solder it from the other side. Okay, so let's see. This, because of it, it's a little bit harder, kinda, sorta, a little bit. Maybe unbend you a little bit more, just to make it easier to put it inside the way I'm trying to do it, like this, yeah, like this and like this. So it's kinda now turned around that tab. And if we just push it down, and we will, but first I want to solder these ones. So if we just push it down, it will fix the shield, the braid of the shield in place. This one is gonna be, oh no, not harder, just maybe cut it a little bit longer. Oops. Ah, okay. Let's solder one first, and then put another one through and solder it to like this. Oops. This thing got out from underneath the tab. Okay, let's first solder it. like this. I don't know, I'm not sure how to use that tab, crimping tab for the shield part of the cable. So maybe some other way you're supposed to do it. Or maybe there's no like the right way. Or maybe there's guide by Amphenol how to do it properly. Who knows? Here we go. So now I think it's safe to crimp that tab inside there. Like this. Actually, maybe you're supposed to pre-solder for this type of fixing the shield. You're supposed to pre-solder it, or maybe at least the tip of it. I don't know. Not sure if this is needed, but I do it just maybe to make it stuck inside a little bit better. So, now this part we are cutting off. It's going to fall apart if I don't catch it immediately. Now the crimping part. This one you cannot bend with your hands, with your fingers. Like the ones that I got from AliExpress, on the ones that I got from AliExpress that I don't think even have a brand. Okay. This thing goes on. Covers everything properly, and then this goes on. Because this is really tight in there. It's not the right diameter of the gasket. I'm kinda pushing it on at the same time as turning. Okay. This one's done, the short one. For the more expensive card. Yeah, the length's supposed to be right, but if the length's not right, well, I measured everything twice. If the length is not right, then I'll cry, of course, but I'll have to simply redo it. Okay. First, of course, the shield, the ground connection. Not shorted, neither to the ring or to the tip. Now the ring, not shorted, but connected to itself, and the tip not shorted to anything, connected to itself. Perfect. And the last one. The last one, like last one. So this one's going to be a little bit harder because the connector that I'm going to use, the jack that I'm going to use for this one is already used. So we'll have first unsolder it. But that's one side of the cable. Another side of the cable is going to be the AliExpress jack, not Amphenol. Okay. Standard procedure at this point. First unbend everything, make it split, go a little bit apart. Here we go. Roughly measure where to cut. Start cutting. Remove the outer insulation. So I have an overhead cam, this one, and this cam I don't know how to call it, but I think I need over the shoulder cam. I kind of had an idea at some point just to mount like what would sort of kind of rafters they would be called. Well, pretty much some structures. Conaton, good evening, welcome. No, not guitar. As you can see, they are TRS, and they are going to be balanced cables for these extenders. So to connect two computers using like analog balanced connection. So to be able to run sound left and right from one computer to another, then microphone from that computer to another, and then microphone back to that computer. Of course, you can do it all in digital. This is analog. You can do it all in digital and over like just your local network, but I wanted to be analog. I want to try it analog. It's kind of a little bit easier when you have at least some knobs, physical knobs you can turn. So, for example, if you don't like the volume of your microphone or whatnot. And yeah, that's what it's gonna be. Connecting two pieces together to make streaming double vision easy streams sitting next to each other a little bit easier. And these are cable extenders that use RJ45, well, twisted pair, category 6 Ethernet or 7 shielded, to carry 4 balanced signals. So, yeah, a little bit insane way to do it when you have like these days voice meter, you have NDI codec that people use to send image from one computer to another, from one BS to another. That's how it works pretty much. But I'm gonna try to do it good old way, analog way. And video capture, of course, going to happen just with a small USB capture device. So, as you can see, for the amount of connections that I need, we're gonna need 8 patch cords, TRS balanced. This 4 to one audio card, and on the other end the same thing to another audio card. So for this, four on one side, for another side, that's like 8 patch cords. hardest part. Insulation of these ones. It's like super stiff. I'm cutting it on my finger again. Finger works as a stopper for the knife. So, complicated audio setup, and I'm not talking about your standard audio cards. I'm talking about audio interfaces that all have jack connectors on them. USB audio interfaces like if you don't know what I'm talking about, Focusrite, Focusrite Scarlett, headphones, phone 4 balance cable from an amp. Yeah, cool. No, I don't do that, but I kind of want just to connect two PCs with balanced audio cables. I mean, and these are going to be actually my first balanced connections used on like well, how to say it right, it would be used occasionally, but it's going to be installed sort of kind of permanently. These thingies, I bought like clamps for them that just clamp them to both desks, one to one desk and one to another desk, and they will be like that. Plug it in, connect, and it will just stay there. I think not even going to unplug it. So would be of course used only occasionally, not going to do like double vision streams every day or even every week. But it's gonna be just nice to have this problem solved. And yeah, I have another computer just behind me, another PC, proper, pretty powerful, not as powerful as my main rig, but more than enough powerful to play DZ. So, and the idea of it of course is not just to be able to play DZ in it, to have a completely free spare PC. If something bad happens with the main rig, then to seamlessly switch to another PC. Yeah, that's my fear of of malfunctions. So strong that I got the second. It actually happened kinda semi accidentally that I got that powerful second PC, and it has, I think, 12700 in there, 12700K or maybe 12600K maybe, and GTX 1080. So that's more than enough for DZ. That's the second PC that's like spare, and for occasional double seat, well, not double seat, it's technically even separate different desks, but gaming as a team sitting in one room. How would you call it? What would you call it? Like, it's used to be called LAN parties, but I think for a LAN party you gotta have a little bit more than two PCs. Okay, pre-soldered it. So, and I'm making my own cables here because they're freaking too expensive. Okay, yeah, everything's right. They're freaking too expensive to buy ready, and I'm kinda I cut them really just to the length. So even if I just move the things around a little bit, the audio interface, the breakout box, I'd have to use probably different cables. So just to how to avoid cable management, yeah, don't have a lot of cables. And my second PC, spare second PC, was supposed to be something like old Xeon CPU running on a Chinese motherboard. I bought all for cheap on AliExpress, but I ended up with like more proper stuff. Ended up with more proper PC. Well, I mean, there's nothing bad in these Chinese motherboards, and especially nothing bad in these old Xeons, because they're Intel. They cannot be faked, and there's no need to fake them because there's a ton of them commissioned from data centers. So still good for like gaming and whatnot, just using. The motherboards on the other side, Chinese motherboards, they of course can be a little bit unreliable and maybe a little bit like even glitchy at some particular rare moments, but I mean, if you're not doing anything mission critical, an old Xeon CPU from AliExpress and a board like this can get you actually a long way. It would be gaming really on a budget, but of course you would still need video card. Okay, now you. More solder. Okay, the back side is done. Now the sides. So I'm not covering and pre-soldering this big one, the twisted together shield, the braid, because I probably won't be able to just fit it through. It would become a little bit too stiff. Up a little bit, wait to start taking solder properly. Like this, and then cut the excess of it, cut pretty much everything off of it to make it like as flush as possible. A little bit overheated it again. Just like this. Yeah, I think I will need new ones after this, making them pretty dull. And a little bit of solder on top. With flux, of course. Again, I keep saying that, I keep explaining, but people might be joining and leaving and rejoining. I'm soldering everything using a pretty old method. So the solder itself is standard, low temperature, a mix of tin and lead that everybody uses, but the flux is a pine rosin flux, so that comes in just sort of kind of, I don't know how to call them, transparent rocks, yellow. So it melts under the soldering iron, and it's 100% natural. Well, maybe not 100% these days, nothing's 100% natural these days, but it's natural to a high degree, and it smells good. I mean, I like the smell of it. Okay, creamed. Stop. This singing. Like this. Properly on all the way. One side is done, and then the last connector, last jack of the evening. But first we gotta prepare it, because this one's used. It's gonna be a little bit harder because of that. So let me just get rid of everything here that's getting in the way. These amphenol jacks, they cost $6, $7, $8, $9 here, so that's why I'm reusing them. Oh yeah, I'm gonna need a helping hand with this, the third hand. Plus I would want to clean the holes, make them holes again. Before I forgot, let's put this all on the cable. So, very basic helping hand, super basic. Oops. Unsoldering it without even cutting, just unsoldering. This one's going to be harder. Here we go. Didn't cut anything, didn't leave anything on the pads. Now the question is how to make it great again. Okay, we have one hole back. We just need another hole. We need to suck the solder off of it. For that, I think the best way would be just to get rid of all the solder on the soldering iron. I mean, I don't want to go for the braided wick. Or we might need actually braided wig. Yeah, there's a little bit too much of it. Okay. Where's the open one? That's the ones. The one that's used. Did I use it up completely? I do look through it. Okay. And you pack them. Okay. Immediately made it not flat. Yeah, tons of solders you can see. But at least it works. Sometimes it's hard, especially if you're dealing with boards, with PCBs. It's super hard even with braided wig to remove the solder from the holes. Okay, almost opened it. Almost opened it up. Want to do everything, well, by the book, not by the book, by my OCD. And what we have inside the hole now, it's flux. It's not solder. Here we go, perfectly clean pad with a hole in it. Now the same let's do here. Hope you can see what I'm doing. Probably got to zoom in just to show it the best way possible, because why not? Since this camera can zoom in like to this level with this lens. Yeah, the focus cannot get the focus done at this level. Because probably the lens wasn't screwed on to the end. It can zoom in farther than it can do focus for. Okay, that's like not a microscope, but good magnification. Very good magnification. A little bit of flux, of course. The wig soaks in the solder and cleans the pad. Here we go. As you can see, the hole's there. Here we go. So now this can be like easily reused. Maybe let's clean this side too, just because we can. Just because we can. Maybe a little bit of, just as a little bit of practice using this week. Still kind of moving in this clamps, crocodiles, but better than just having it freely rolling on the table. The thing with wick that you actually can, it's just copper, it's just wire, you can pretty much solder it to the pad you're trying to clean. That's what I've just done, and because it is freaking moving, I cannot unsolder it properly. Oops, sorry. Not in the frame. Apologies. Well, I guess as clean as we can get it. Yeah, okay, enough experimenting with wick. So we have the hole, and we have overheated the jack itself, but yeah, we have the hole, both holes. We have the tap over there. So maybe actually the matrices and these cameras that I have, this one and this one, they are not that good, but the lens are not amazing, but they give you like magnification like this, which is sort of kind of pretty cool. Not a lot of just standard USB cameras, not a lot of even photo cameras that people would use for taking video. Not a lot of them can do this. No, this one's manual focus. And the depth of that focus field is not that big at all. Okay, zoom out. Here you go. What if I make this dot of flux here my mark? Okay. Okay, this connector's ready. The last one. So let's just prepare everything and solder the last one. Not just the last one in general, but the last one, not just the last one for tonight, but the last one in general. Oh yeah, that's a problem. Got to zoom out a little bit more. Yeah. Like this maybe. Framing, I'm telling you, framing is super hard tonight. For some reason. Framing and focusing. Like this. Okay. Preparing it like this. Twisting it together. Like this. Pretty much. So now the hardest part of the whole ordeal is removing insulation from these ones. And the last hard one. Well, they're pretty actually stiff, so can call them like that. Did I pull it out a little bit? A little bit maybe. Like really stiff. Get in the way, the red one. I think I'm brushing the microphone with my head here. The microphone, I'm using just my usual microphone with just amped up sensitivity and additional amplification, and it's working right now like just as an overhead mic. That's probably why you're hearing way more noises. I used to use headset microphones, and I would still use them if I need to move around a lot. But if it's just at my desk, yeah. Okay. Almost there, almost done. Covering it and pre-soldering it. The knife I hope we are not going to need anymore tonight. Yeah, the tip is dirty as hell because of the pine rosin flux. That's what it does to soldering iron, especially if you use burnt pine rosin flux. Okay, and I'm not covering and solder the shield twisted together, the braid of it, because it will become very stiff. It won't go in its place, and here it's that place is a little bit even more complicated than just a hole in some tab. So let's unbend this, because it's not really a hole. It's actually a hole in and a tab on top of it. I'm kind of doing it like this, pushing it under that tab. Move the tab a little bit down, and then this. A little bit too long they are. Okay, we will force them, even though they are very stiff. Like that. Okay, because they are very stiff, let's first solder one. Here we go. And then the same we got to do with another one. But you bend these pads, tabs, whatever you call them, contacts. You just bend them, literally and figuratively, to your will, like this. Here we go. This one's ready. Now that strange way of no, I don't know if you can see it. Let me actually zoom in to show the way I'm doing it, and I'm not sure if I'm doing it right. That's the connect. Crap. That's the zoom. So now you can see that tab that I was talking about. Interesting design. I'm not sure how to use that tab properly. I use it like this. That's how I use it. And then, because I'm like that, I add a little bit of solder steel on the other side. I don't think it's necessary, but I do it anyway. I want to go inside the hole. Make a contact with the twisted together shield. Okay, now let's cut the excess of it. And zoom out. So these cameras are not the best when it comes to everything that's related to its matrices, but the lens that are not, again, the best lens in the class, but they are still lenses. They allow you to do things like that. Serious zooms, which is perfect for this type of streams. Reused this jack. It used to be on my old headphones. Since everything I have here, it uses like big jacks, not the small ones. Yeah, I kind of cut off the small jack off of like my old pair of headphones and soldered on a proper Amphenol big jack. Okay, you go like this there, and then carefully pulling over the casing. Carefully, because the size of the gasket here is not right for this cable. Here we go. Look almost the same, but they're different connectors. This is Amphenol jack, and this is well, I mean, this different manufacturers, and this is from AliExpress. But look how close they are. It would be actually hard to tell the difference. This one has Amphenol kinda embossed on it. This one doesn't, but yeah, it's hard to tell them apart. This one has like what's called knurling here. This one doesn't. Okay, let's test it. That was the last one. Let's test it. So nothing without testing. First the ground. Apps. Ooh, that's not good. Wait. Here it is. I wasn't measuring it right again. The ground's here. Not shorted to anything. Now the ring. Not shorted to anything, connected to itself. Now the tip is here and not shorted to anything. Okay, so just a second. That's our work tonight. Job done. Finally. Over like 3 streams. But we soldered, we made the cables I need for this stuff. Like and the same thing would be on the other side of it. So perfect. Finally I'm done with this part. So it was kind of around, I think, 30 to 40 minutes on average per cable. So and they are not just done, they are done the best way I could do it, like the most high quality way, to the best of my abilities. But yeah, enough of soldering for now. Thank you very much for watching, everybody. Don't leave the channel yet, please. I'm asking you, don't leave the channel yet. YouTube people, thank you for watching on YouTube. Please leave a like if you like this video. I think our achievement here deserves a like. Subscribe for more, but we usually play DayZ, we usually play GeoGuessr here. We do these DIY stuff, things, DIY type things. We do PC building, but rarely. Twitch people, thank you very much for watching on Twitch. Silky God 5, welcome, welcome, man. I'm just wrapping it up. Thank you very much, people, for watching on Twitch. If you are not following me and if you like the stream, please leave a follow. Activate your notifications, doesn't matter if you're watching me on Twitch or on YouTube, because even though I stream when it's nighttime in Europe, it's pretty wide window, super wide time frame, so notifications will help you to catch me online, to catch me streaming. I stream every day, yeah, but I tend to do shorter streams. And Twitch people, let's do a raid. We always raid somebody when we wrap things up here. So let's raid somebody. So this guy raided, this guy raided, this guy raided. Okay, let's take a look maybe at the science and technology section of Twitch. Since I'm currently in the science and technology, maybe let's see if we can raid somebody soldering something. Okay, Narod doing some KiCad. Okay, I see one person seem to be live. There's a lot of automated streams, like the majority of streams, unfortunately, in science and tech are automated. That's not fun at all. Oh, for some reason I cannot open even the stream of that guy. Is it Twitch? Can I open any other stream? Oh, yes, I can.
Back out.
Okay, that was a random stream. Twitch reports an error. The video download was cancelled. Okay, this guy is building a NES from scratch. Okay, that's serious. Let's see, the chat seems to be not restricted in any way. Let's see if we can read that person. Yep, let's go and say hi to RP Casanova. That's some soldering on a completely different level from mine. Yeah, I have a lot of experience in soldering like wires, but microelectronics not that much. So let's go and say hi to RP Casanova, who is building the NES motherboard. And I will see you all tomorrow. That's it for tonight. Goodbye and good night, and thank you very much for watching again.